Okay, let's unpack this. Today we're really diving deep. We're looking at what happens when things go seriously wrong. When a standard emergency call blows up into something huge, complex, needing multiple teams.
Yeah, and this source material we have, it's basically the playbook, isn't it?
Yeah.
It lays out the structure, the rules responders follow to manage total chaos.
Exactly. Whether it's a massive building collapse or, God forbid, some kind of chemical attack.
Our goal here is to really pull out those core frameworks, things like the zone system for hazmat or that color-coded triage system. These are the tools that let responders impose some order and, well, save as many people as possible.
And right at the top, the absolute first principle always is safety first, right? Protect yourself, protect bystanders. If the responder isn't safe.
They can't help anyone. It sounds obvious, but it dictates everything that follows. You can't just rush in. You have to understand the danger first.
Which brings us straight to hazardous materials hazmat. What exactly counts as hazmat, according to this?
Basically, anything that's toxic, poisonous, radioactive, flammable, explosive, you get the idea. Stuff that can hurt or kill you if you breathe it, touch it, or swallow it.
Okay, so the big challenge, especially if it's like a spill or something unknown, how do responders figure out what it is they've stumbled into, say, on a highway wreck?
It really comes down to standardized systems.
Mm-hmm.
If it's being transported, the first thing you look for are those diamond-shaped placards you see on trucks or containers.
Ah, right, the DOT placards.
Exactly. They're part of the U.S. Department of Transportation system, and they match up directly with the Emergency Response Guidebook, the ERG. It gets updated every few years.
So that placard is like a quick reference flag if I see, say, a number 3 in a red diamond.
Flammable, or a skull and crossbones with a 2.
Inhalation hazard.
Yeah.
Got it. So the ERG tells them what to do immediately.
Yeah, initial isolation distances, what kind of protection they need. And a huge part of that protection is setting up safety zones, thinking geographically.
Okay, let's map those out. Because for anyone listening, knowing where not to be is crucial.
Starts with the bullseye, right? The hot zone.
Right. The hot zone is ground zero. Highly contaminated where the actual release happened. The rule is simple. Only specially trained people in the right suits with the right gear go in, period.
Okay. Moving outwards from there, you hit the warm zone. What's its job? Is it just for parking the trucks?
Oh, no, it's absolutely critical. The warm zone is all about contamination control. It's where decontamination happens. Anyone coming out of the hot zone has to go through decon here.
Decontamination. So washing stuff off, basically.
Gross decon, yeah. Getting the worst of it off. It's also where they stage equipment needed for the hot zone. Think of it as the airlock. It keeps the contamination from spreading outwards.
So if that warm zone gets compromised, the whole scene safety breaks down.
Pretty much. It protects the last zone, the cold zone.
Which is the safe area. This is where the command post is set up, where maybe ambulances are waiting. Exactly. Support functions, medical treatment after someone's been decontaminated. If you're a bystander, the cold zone is the only place you should be, and even then, you need to be directed by officials.
Okay, so hot, warm, cold. It's a physical structure imposed on the chaos to manage risk. Makes sense.
And once you have that geographical control, you often face the human side. Too many injured people. That brings us to mass casualty incidents, MCIs.
Right, defined as what? Like a big car pileup, maybe an explosion?
Yeah.
Something with 3 or more patients.
3 or more, yes. But the key part is that it overwhelms the initial resources. Suddenly, one ambulance crew facing 10 critical patients. They have to switch gears mentally.
How so?
Well, you stop thinking about doing everything possible for the one person right in front of you. You have to think about the whole group. That's triage.
Sorting people based on how badly they're hurt?
Exactly. To do the greatest good for the greatest number. And it's tough. It means sometimes you have to delay treating someone with really serious injuries.
Because someone else needs help right now to survive and has a better chance if they get that immediate help. That's a heavy decision.
It is. And to make it standardized and fast, responders use systems like Start Simple Triage and Rapid Treatment. The goal is speed. Assess each person in 60 seconds or less.
60 seconds? In the middle of all that? How? What are they looking for?
Just 3 things, basically.
Okay.
BCM, breathing, circulation or perfusion, and mental status. And it starts with a command.
What's that?
Step 1 is yell. Anyone who can walk, get up and move over there to a designated safe spot.
The walking wounded.
Yep. They all get tagged green, priority 3 minor, immediately. They're moved out of the immediate chaos. Their care can wait, sometimes up to a few hours.
That's clever. You're not actually treating them yet. You're just clearing the scene so you can see who's left, who's really critical.
Precisely. It frees up responders to focus on the ones who can't walk. Then they go patient by patient, applying the BCM check to assign the other colors. Let's talk red. Priority 1 immediate. These are the most critical who need transport now.
Okay, how do you spot a red tag in under a minute using just BCM?
Any one of these makes them red. First, breathing really fast, over 30 breaths a minute. Second, circulation check specifically, no radial pulse.
Radial pulse at the wrist. Why that one?
Because if their blood pressure is so low you can't feel a pulse there, they're likely in deep shock. It's a quick field sign. Third, mental status if they can't follow simple commands like squeeze my hand. That suggests head injury or poor brain perfusion.
Okay, fast breathing, no wrist pulse, or can't follow commands. Any one of those means red. Got it. What about breathing? There's a really crucial step there, right?
Absolutely critical. If a responder finds someone not breathing, the first and often only thing they do is try to open the airway, head tilt, chin lift.
Okay.
If that simple action starts them breathing, boom, they're tagged red. A quick intervention made a difference. They're potentially salvageable.
And this is the hard part. If you open the airway and they still don't breathe.
Then they are tagged black, priority for deceased or expectant. In the brutal math of an MCI with limited resources, if that simple maneuver doesn't work, they're considered beyond saving in that context. The responder has to move on to the next person they can save.
Wow, okay. That leaves yellow. Priority 2 delayed. Who are they?
Yellows are seriously injured, no doubt. Think maybe major broken bones, bad burns, but not airway ones. But their condition isn't immediately life-threatening.
How do you know?
Their BCM checks are stable. Breathing under 30, check. Radial pulse present, check. Able to follow commands, check. They need help, definitely, but they can wait maybe up to an hour while the reds get transported first.
Okay, so green, red, yellow, black. A very rapid, structured way to sort through unimaginable chaos.
Exactly. It imposes logic where there is none.
Now, this framework applies to accidents, but things get even more complex and frankly scarier when we talk about intentional acts, terrorism, and weapons of mass destruction, WMDs.
Yeah, WMDs are designed specifically to cause mass death, casualties, damage, and the targets are often chosen for impact: big cities, bridges, airports, symbols.
The source material breaks down WMDs using the BNICE acronym but focuses heavily on chemical agents. Let's go through those 4 main types mentioned. First, pulmonary agents. Things like chlorine, phosgene.
Right. These are mostly inhaled gases. They attack the lungs directly, cause coughing, make it incredibly hard to breathe, and can lead to fluid buildup in the lungs, pulmonary edema. Nasty stuff.
Then there are metabolic agents like hydrogen cyanide. Sounds bad.
It is very lethal. These chemicals stop your body's cells from being able to use oxygen. So even if you're breathing, your body is suffocating internally. They can be very fast-acting, sometimes smell like almonds, sometimes odorless.
Okay, next level up in terror seems to be the nerve agents. Sarin, VX. Names we unfortunately know from the news.
Yeah. These directly attack the nervous system, disrupting the signals that control everything. The symptoms are widespread and come on fast. The mnemonic they use is SLUDE.
SLUDGE.
Okay. Salivation, lacrimation, crying, basically. Urination, defecation, gastrointestinal upset like cramps and emesis vomiting. It's a total system overload. Needs immediate antidote treatment.
Grim. And the last chemical category is blister agents. Mustard gas, lewisite.
These cause damage mainly through contact with skin or eyes, or inhalation. The scary thing here is often the delay. You might be exposed.
And feel nothing for hours.
Exactly. Then later you develop severe irritation, burns, and large painful blisters. Very dangerous for responders who might not realize they've been exposed initially.
Beyond chemicals, the source also touches on biological agents.
Right. Using living organisms, bacteria, viruses, toxins to cause widespread disease, think of smallpox, anthrax. The big operational headache here is the incubation period. Meaning the time between exposure and when people actually get sick. Unlike a chemical agent where effects can be instant, with bioagents it could be days or weeks. Makes it really hard to track who's exposed and contain the outbreak.
And finally, radiologic agents. Nuclear materials, maybe a dirty bomb mixing explosives with radioactive stuff?
Yeah. The danger is invisible ionizing radiation. But the safety principles are straightforward, though critical. Time, distance, shielding.
Minimize your time near the source. Maximize your distance from it. Use shielding anything dense like concrete or even earth between you and the source.
Those 3 things dictate your dose, basically.
Okay, so whether it's a chemical spill, a multi-car pileup, or something even worse, you've got fire, police, EMS, maybe hazmat teams, all trying to work together. How do they avoid tripping over each other?
That's where the bigger organizational structures come in. You mentioned NIMS and ICS earlier.
Right. The National Incident Management System and the Incident Command System.
NIMS is the big picture, the national framework that says everyone should play by the same rules. But ICS, the Incident Command System, is the actual tool they use on the ground during an incident.
What makes ICS work so well? It's more than just having one boss, right?
Oh yeah, it's about standardization. First, common terminology. Everyone uses the same names for roles and resources. Staging area means the same thing to a firefighter as it does to a paramedic or a police officer. No confusion.
Okay, that makes sense.
Second, manageable span of control. No single supervisor gets overwhelmed with too many people reporting to them, usually like 3 to 7 people max. Keeps things organized.
So you build this modular structure based on the incident's needs.
Exactly. And it has defined functional areas. Operations, the doers; planning, the thinkers; logistics, the getter supplies, facilities; and finance admin, the payers.
So a police captain could theoretically manage a resource from the fire department within this structure because they're speaking the same organizational language.
That's the whole point. It allows different agencies, different disciplines to plug into one unified command structure and work effectively. Without ICS, large incidents would just dissolve into chaos, different agencies doing their own thing.
So wrapping this all up, what's the big takeaway from this deep dive into these emergency procedures?
Well, it seems crystal clear from these sources that managing huge emergencies successfully comes down entirely to structure and standardization, whether it's drawing those hot, warm, cold lines on the ground or using that quick start triage.
It's all about having a predefined system, a framework.
Yeah. These frameworks allow responders to make incredibly high-stakes decisions under immense pressure, but with clear guidelines. It turns potential paralysis into guided action.
And think back to that start triage logic again. That principle of the greatest good for the greatest number.
Right.
We saw how it forces responders to prioritize those red tags, the immediately salvageable sometimes over others who might look worse, but are deemed unsavable with current resources, like the black tags, or even making the yellow tags wait.
So here's something for you, the listener, to think about. We usually picture medical care as doing absolutely everything for the one patient right in front of you. How does that core idea get challenged, maybe even temporarily suspended, by the ethical demands of an MCI protocol, where the collective survival, the greatest good, has to take precedence? It's a really fundamental tension in emergency response.